This how-to tutorial will cover the method I use to create my own version of a line-of-sight vision system. This type of vision system can be used to create really cool cinematic effects, and types of this system can be seen in games like Darkwood or Monaco. This is my first time using the chapter system on YouTube for my tutorials, rather than breaking it apart into smaller separate chunks, so we'll see how that goes. I will also have a written version of this tutorial on my documentation page. Since we're breaking down the development of this line-of-sight vision system into smaller, more manageable chunks, we're going to start here with a post-process material that we're going to create to kind of handle the logic we need. And we're going to build upon it as we go. So I'm here inside of a TwinStick game. Nothing has changed here except I've added in a quick PNG. It's called sample render target. I'll make sure this is available on the documentation page, the written documentation page that goes along with this video. The only thing special here is I've made a 1800 by 1800 image. It's got some black area and some white area that we can basically use for some masking purposes. So I'm going to go ahead and create a new material here, and I'm going to call this one LOS Vision Post Process. I'm going to wander over to our post process volume, and I'm going to go down to post process materials, and I'm going to add an option to the array here, make it an asset reference, and drag in this material I just made. We're then going to pop in here, and we're going to make some modifications to this material before we actually start writing, making nodes here. The first thing is I'm going to make this into a post-process material domain. Then I'm going to go scroll down all the way to the bottom just about, and I'm going to change blendable location from after tone mapping to before tone mapping. And this is just to avoid some jitter issues with the temporal anti-aliasing that Unreal uses by default. All right. So the concept we need here is I need to have a region of our screen that has the normal game screen and then a region that has just black or some other color. So what I'm going to do here is I'm going to add myself an lerp node. Let's call it. I hold down the L key and just clicked, and I'm going to hold down the V key, and I'm just going to give myself a color. And I'm going to change this for now for development purposes to something more obvious. That we know that we are not basically inside of, and this isn't any shadows. I'm also going to right click and get myself a scene texture node. The scene texture node is our window into the different render passes that the deferred render system in Unreal uses, and I'm going to use post-process input 0. This is going to actually give us just the general render from the screen. I'm going to connect that there, and I'm going to wire that to the emissive. And to fix this error it's going to give us, I'm going to give this a mask component. This is because this is actually a vector 4, and it needs to just be a vector 3 for this. And that'll take care of that. And for our alpha pin here on our lerp, I'm going to use a texture object. And I can't plug our texture object. We're going to use our sample render target. I can't plug this directly in here, and I can't add a mask in. If I try to use a mask, it doesn't like it. We're going to actually use a world-aligned texture. This is kind of the magic node that we're going to be using that's going to let us apply this to the world itself. I'm just going to use that Z texture because it's kind of already set there for just having one channel for our alpha. Go ahead and hit apply, and we can even take a look now, and we can actually see that we're already starting to get this to show up here on the world, kind of like basically applied in the Z direction. So this thing we need to do is just actually tell this what size this texture object is. So I'm going to hold down V, I'm going to add in another vector node here, and I'm going to plug that into texture size. And we're actually going to go tell it that it is a 1800 by 1800 image. Just for consistency's sake, I'm going to make those all 1800s. And now if I hit apply, and go back to our world, we can see that we have this larger shape still repeating throughout the world. But if I hit play now, you can see that I can wander in and out of view, and the objects that are within that space in 3D do in fact appear where they're supposed to be. Everything else does not end up showing up. So there's our first step. The next thing we're going to do then is, this would be really, really handy to actually have centered on the player themselves. So we're going to actually center this on the player. So in order to actually kind of move this texture around them with the player, we're going to actually utilize a collection parameter. And we need to actually create this. So let's go ahead and create that now. I right click here, I'm going to go down to Materials and Textures, and I'm going to create a material parameter collection. I'll go ahead and call this player position. And I need a vector parameter because I need their location in 3D space. And I'm going to go ahead and expand that out. We're going to name that player position. All right, now that that's been saved, I'm going to go ahead and point this towards player position. I'm going to use the parameter player position. And I can't directly utilize this here. I can plug this in for the moment, but you're going to see an issue here. Let's go ahead and just apply that, and then we'll fix this afterwards. But remember, this should not be connected directly there. So I'm going to wander over to our TwinStick pawn. I have it open here. We can actually find it a couple different ways. We can click there, edit blueprint, open blueprint editor. That'll get you there. And I am going to go ahead and in the event graph, I'm going to override the event tick here. I'm going to add another sequence here for this particular thing. And we're just going to move these down for cleanliness. I'm going to drag out of here, and I'm going to say set vector parameter value. And under collection, I want to change my player position. And for the name, I want to change the player position. And for its parameter value, I'm going to go ahead and split this structure out. And I want to just get actor location. I'll go ahead and split that out. You know what? We don't actually need to split that. I'm just going to recombine these. Just drag that in, and I'll let it convert it. And that'll be fine. So now, every tick, we're going to update where our position is on our vector parameter value. Now if I hit play, you're going to see that you're never going to actually see anything. I promise I'm moving, but you're kind of seeing everything is kind of going wonky. And this is because we actually need a shift, basically, not an absolute position. So we want to take our world position, and we're actually going to subtract these. So I'm going to mask this because as you can see, this is a float 4, and I want to do some float 3 math. And I will subtract. And so I'm going to take this position, wherever this position is in world space, and I'm going to subtract from it to create a vector towards that position in world space. I'm going to plug that into my position now for my world aligned texture. And I'm going to go ahead and apply. Now if we hit play, you can see that those positions are kind of staying still, but it's not quite centered on us. This is because it is currently centering it at a corner. Remember, this is 1800 by 1800, so we have to add an offset. So we're going to go back here, and we're going to go ahead and we're going to add an offset. And then we're going to go ahead and make a float 3. And we're going to go ahead and hold down S, give ourselves a scalar. And this is going to be called offset. XY. And we're going to set this value to 900 because we want to center this image on us. So now that I've added those together like that, I'll go ahead and hit apply. Now if I hit play, you'll see that this is now centered on our character and it is now following us around. So we now have the basis for a post-process material that we can begin building a way to create a more custom image that we can use rather than our sample render target to actually create and draw this vision field out with. So this first step is now finished. The next step then, we're going to talk about how we would potentially create dynamically during play and render to a image some kind of a map, PNG basically, that we can then use for this. All right, so to start creating a custom shape that we can then use in place of our texture object that we have here, the first thing we need to do is actually create a target that we can draw to. So go ahead and right-click under Materials and Texture. We're going to create ourselves a canvas render target, and we're going to call this one LOS Vision Zone or something. Just LOS Vision Target is what I'm going to call it. And we're going to jump inside of there because we need to make some modifications. The first thing we need to do is make sure that we make this 1800 by 1800. And this is just for my purposes of this example. You can make this larger or smaller for whatever you need. If, for example, if I hit play here, you can still kind of see on the left-hand side there that we still do have like the text repeating and such. So if you have the camera pulled back more, a simple solution would be just make this material larger and then it won't end up repeating. So 18 by 100 by 1800, that's fine. We also want to make sure that this is not generating MIP maps. So no MIP maps. We only want this as a raw data. Go ahead and save that. And then this is basically what we're going to be trying to draw to and work with. So we're going to open up and we're going to go back to our TwinStick pawn here. And we're going to give ourselves some space to work with. So instead of just setting this vector parameter value, what we're going to do is we're going to create a custom function here. And we're going to call this one LOS Vision System. Go back to our event graph, and we're going to run our LOS Vision System basically every tick, because we need this to update every single tick. Unfortunately, there's no real way around this. This is one of those mechanics that I can't actually push off of the event tick, nor would I really want to. I want this to occur every frame because every frame the character may be moving, and that's important to constantly give them new information. All right, go ahead and delete those after copying them, and we're just going to move those into our vision system. And so we're going to get our get actor location. We're going to set vector parameter value, player position, and give it that. Okay, so here's our sequence then. We're going to give ourselves a sequence here. This is the first thing we want to do, is update this positional information with the player. And then the next thing we want to do for this node, and this is going to be update the LOS render target. Okay, and so to do that, we just need to actually first basically get a reference to it. So what we're going to do here is we're going to clear render target 2D. And I'm going to use this just to get the right asset here so that we want. So we're going to promote this to a variable. This is going to be our LOS render target. compile that, and we are going to point that towards LOS vision target. So step one, every frame we know that wherever we're working with, we have to clear it. We're going to clear it to the black color, so that's good. Then add ourselves a reroute node. We know that we want to begin drawing to it. The next thing we want to do is we want to draw a triangle. Not draw a material triangle. We just want to draw a triangle. I got that from dragging out from the canvas, so I get that reference. And we can leave render texture as just empty, default. We're just going to use white. That's all we really want because it's going to give us a value of 1. And then we have to drag out from our context pin for afterwards, just so that we can basically let each frame know that we are done drawing it. After we draw our triangles, we're done. And so let's go ahead and give ourselves a sample example triangle we can draw. So I'm going to go ahead and I'm going to say make. We're going to make an array from here. And I'm going to go ahead and split this structure pin out so that we just have basically one version of this, so we can see what this particular thing is trying to ask for. And it's asking for an array of these. And what these are basically 3 copies of the same kind of information sets. We have position, UV, color, position, UV, color, position, UV, color. And so a triangle is 3 points. These are basically 3 vertices. So we have a vertice position, a vertice UV, which we're not going to utilize, and then the vertice color, which we will end up utilizing when we actually draw out to the triangle itself. So what we're going to do here then is just add in some generic values so that we can kind of see on this picture here what's going on. So I'm going to leave this at 0, 0. I'm going to make this one 1800, and I'm going to make this one 1800. So I've basically made vector 0 of our triangle 0, 0. I've made vertex 0 of our triangle 0, 0. I've made vertex 1 of our triangle 1800, 0. And vertex 2, 0, 1800. And we do need to change the colors here to pure white. So now if we simulate this, we will still see this kind of empty grid pattern. That's just because we have the alpha channel enabled. So if we don't use alpha, you can see that everything is now being drawn white. Right, stop that. And so there's the simple concept of how we actually will draw to that image. If I actually switch our vision system over now here, this is back in the LOS vision post process. I'm going to go ahead and close this this collection parameter. I can actually switch my texture object now over to our LOS vision target. Go ahead and apply. And you can definitely see that now we have a very strange shape that we're kind of dragging around the screen with us that we can use as a mask. So let's go ahead and actually make it somewhat more useful in a way that we're going to be building upon later to make this a actual like dynamic LOS system. So the next step is to then test this system out by creating a centered static kind of triangle shape that we're going to use as a rudimentary vision cone. We're going to do that by basically giving ourselves sort of a static single triangle that we'll work with, but we're going to base it off of our direction. So I'm going to go ahead and get actor forward vector. And I'm going to go ahead and get actor right vector. And we're going to use these then to kind of override the vertex positions of our triangle. So I'm going to go ahead and multiply this out by a float. Let's say 700 for the length of our triangle. And then I'm going to give myself add vector. And I'm going to give myself a subtract vector. And I'm going to go also ahead and copy this node right here. And we'll leave that at like 700 is probably fine. And so now I have the right vector and the forward vector, a 700 length of those directions. And I'm going to add and subtract those both. Now the next thing I need to do is actually shift these, because if you remember, for our vision system, 0, 0 is right there. So I want the first vertex of our triangle to be at 900, 900. And then I want whatever the addition of that is to be based off of that position. So I'm going to go ahead here and I'm going to add another vector. And we're going to do a make vector. And this is going to be our offset. Go ahead and label that offset. Going to duplicate that. Add that there. And then I will plug the offset into our vertex 0 so that we can start it at 900, 900. And then our vertex 1 will go to this position, and our vertex 2 will be located there. Just cleaning things up a little bit. Now let's go ahead and compile that and test it out. So if I simulate it, there we go. We have a simple triangle that we've drawn. If we run over here to the game, instead of simulating, actually hit play, we can see that we do have a vision cone, but if you look carefully, you will notice that it's kind of behind us. And so we actually need to reverse and modify how the line of sight system here is treating it, because we want to write to this image in a organized fashion such that forward is forward and right is right. We don't have to worry about any kind of math over here. We'll just handle like any switches over here. So what we will do here for our positional data is we're going to go ahead and break this component out. And we're just going to reverse some directions on things. So multiply by -1. Copy that, paste. And now I'm just basically reversing the coordinates for my x and my y. After that, I will remake this float 3. Just give this a reroute there to make it a little bit cleaner. Let's go ahead and drag that out, and we're going to put a box around that. And this is going to center the view. And we'll plug that into our world position. I'm going to go ahead and apply, and now we can go ahead and test it, and lo and behold, it is now working properly. So there is now a triangle in front of us based on our forward direction at all times. And so in the next step, we're going to, instead of just writing a static shape here, we're going to create a system using line traces that will then basically sample the environment in front of us and then draw out the shape accordingly. So in order to create our own custom shape here based on our environment, we're going to utilize a series of line traces. And we're going to talk more about why we'll need it, but we're going to need them to be somewhat ordered. So we can't just cast out randomly or start at the middle and go right, then left. We're going to start at the left, and then we're going to move our way right. So let's go ahead and jump into our TwinStick pawn here, and we're going to go ahead and create ourselves a new function. And we're going to call this function createCone. And so the first thing we're going to do here is we're going to get our actor forward vector. And what this is going to give us is a reference direction that we can start using for what is forward. And so we're going to actually grab ourselves a rotate here, because we're going to rotate our forward vector. And we need to rotate this a bit so that we first start at the left, and then we start rotating back to the right. So we're going to start make a rotator here. And we need then something that we can kind of modify as we go if we decide that we need more points later on. So I'm going to give myself two variables here. The first one I'm going to have is an integer. This is going to be num traces. And my float variable here is going to be degrees per trace. And this is going to be a how many degrees should there be between one trace and the next. I should note here that when we're using this, the num traces should stay as a even number. If it's not even, you're going to potentially encounter some issues here. So I'm going to go ahead and compile this just so I can set this as like 20. We'll start with 20 traces. And then for our degrees, we'll go with like 3 degrees per. And what I'm going to do here is I'm going to multiply these together. And then I'm going to divide it by -2. The reason I'm dividing it by -2 is because I first off only want to move my rotator or my forward vector halfway to the left, and so half of that is going to be the 2, and then the reason for the negative is to indicate it should move to the left. And I'm going to connect that to my z-axis, so I'm going to rotate my forward vector in my z. I'm then going to give myself a for loop here. And this is going to control the number of traces we're actually going to occur. So I'll go ahead and just, for cleanliness, I'm just going to drag another copy of num traces out. We're going to connect it to our last index. And then I'm going to take my degrees per rotation here, and I'm going to go ahead and drag out. So actually, let's get a new one here. We're going to get ourselves a multiply. We're going to multiply that by our index. And the idea then here is this new rotation starting from the left, we're going to then rotate it again. And we're going to go ahead and split this. And we can then rotate this slowly back to the right each for loop. So let's go ahead then with this. We can now go ahead and make ourselves our line trace. We'll do a line trace by channel, and so we can kind of see it. We're going to actually draw debug for one frame, so this will keep redrawing it each frame as we create it. We want this to start at wherever our actor is, so we're going to do a get actor location, and there's our start. And then for the end of this, we basically want to take whatever direction this vector is currently pointing in, multiply it out a little bit so it has some length. So let's say 700. And then we're going to then add these two together so that we can kind of go in that direction. And let's see how this actually looks on screen. So let's go ahead and compile this. Go ahead, play. And before we actually get to see it, we actually have to indicate that it should run this function. So let's go back into our event graph. So we have this line of sight system we're using. So the first thing then we're going to do is we're going to add another thing to the sequence here. We're going to then move the pins down so that the first thing we do is set our position. The second thing we do then is we run this create cone function. Right, now that we've compiled that, we can see that we now have a very ordered series of lines here that we're casting out, and as we move around, they're going to basically be sampling the level in front of us and around us. And you can then set this basically for any kind of width that you want, for like if you want like your player to have a narrow cone of view or like a wider cone of view. And you can add more points then if you need it to be a much more finer mesh. So now that we are actually drawing our line traces out, we need to save this information. So let's go back into our create cone function. And then the last thing that we need to do then is, based on our hit results, we need to save something. But we need to be careful that we're actually saving useful information if there is no information. So if I hit play here again, you can actually see that if we don't encounter anything, if everything is too far away, we don't get a line trace result. There's no kind of point there that we're actually going to get. So the idea here is we need a branch statement that if we are hitting something, we want to save the location that we encountered an object. If we don't hit anything, we want to save the position that the line trace ends at in space. So I'm going to go ahead and add a branch. And the condition it's going to run off of is this return value. If there was a hit, we want to save the hit. If there wasn't a hit, we want to save a different value, basically this end pin. So I'm going to go ahead and just, for now, add a reroute node here so that we can then reroute this around here. And we'll spend a little bit of time right at the end here kind of cleaning this up visually. I'm going to go ahead and split the structure pin. And so now we need to save this somewhere. So what we're going to do here is we're going to add ourselves a new variable here. And this is going to be trace results. And we're going to make this a vector, and we're going to make this a vector array. I'm going to add in a reference here right at the beginning, because the first thing I want to do is make sure I clear this. Every time I use it, I'm going to have different results, so I need to make sure that I clear this every single time. Now over here what I can do is I can add a new result each time so that I know that entry 0 is the first line trace, entry 1 is the next one, and so on. So I'll have an ordered trace result that I can then use. I'm going to go ahead and copy that for the false, wire that back up to the trace results. And so now our out hit location, if it was hit, we'll add it there. If it wasn't hit, we'll go ahead and add in the end position that we actually created, or actually using for the line trace. So now we have this ordered pair, or this ordered series of points in space. So let's go back to our line of sight vision system. And this is where we can then utilize this information. So we're going to go ahead and actually get rid of this. In fact, this also. And we're going to make ourselves a new function here that we're going to use to prepare everything. So we're going to go ahead and drag this down. And we're going to create ourselves a new function here then. We're going to call this prepare triangles for canvas. Now let's jump back real quick to our line of sight system. And we're going to go from this triangles thing, we're going to drag off of this, and we are going to promote this to a variable. And we are going to call this one canvas triangles. So now let's go ahead and, while we're here, drag out prepare triangles for canvas and just wire that into the sequence and jump back inside, and we'll actually start preparing this. So the first thing to do then is grab a reference to our trace results, and we're going to grab a reference to our canvas triangles. Now we're going to take that canvas triangles reference, and we're going to make sure that the first thing we do in this function is we clear it, because since we're running off of each frame, and each frame our trace results will change, we want to make sure that our canvas triangles is cleared so that we have a clean array that we can then pass over to the canvas. And we're going to then take our trace results, and we're going to grab ourselves the length, and we're going to use this to run a for loop. And we need to subtract an integer from our length so that we can run it through the last index. Now we don't want to leave this at -1. So if our trace results is like length 20, 21, etc., we don't want to simply do the standard -1 for the last index because we actually are going to be going forward 1 each time that we run. And what I mean by that is we're going to use our index to grab ourselves a reference. So let me grab that right now. But this is only going to get us one of the vertices of the triangle. Remember, since we're going from left to right as we're drawing through all of these line traces from the array, we need to get whatever index we're currently on and then the following one so that we can create a triangle out of it in our position. So we're going to make this -2. And then we're going to go ahead and drag this down here and get ourselves a second get reference. And I will simply wire up the first one to the index, but I need to wire up the next one to the index following wherever I currently am. And then this will get me the results, so I'll have 2 of them, the current one and the following one that I can make a triangle out of, along with my own position. So the next step then is to grab ourselves our canvas reference, our canvas triangles reference. We're going to add a new we're going to add a new index to it. I'm going to go ahead and wire that up, and we're going to go ahead and split this out. And this is where we have to remember we can't just send it our current position. We need to send it a relative change, since we're going to be drawing that again to the canvas. So we're going to go ahead and get our actor location. And we need to then also grab ourselves a offset. So we're going to go ahead and make vector. And this is where we're going to plug in the 900, 900 again. And we can just plug that directly now into vertex position 0. And for these other ones then, we need to then subtract, because we want to draw a vector from our location to their position. So we're going to do the position in space minus our actor location. And this gives us a vector that's pointing that direction. And then we're going to add the offset vector to that. And then we will put this first one into the vertex position 1 then. Let me drag this out a little bit more. And we're going to go ahead and copy this, paste it. It's going to look a little bit messy until we get the pins attached. And then so the position of the following index minus our actor location, and then add that result to the offset and plug that into our vertex 2 position. And then the last thing to do is make sure we change our color for each of these back to white to indicate a value of 1 for our mask. All right, let's go ahead, save that, and try it out. All right, and so lo and behold, there is our vision cone that is now changing as we encounter things. And you'll notice something interesting here. This is something just I prefer to do. You'll notice it's kind of acting really strange when it encounters a space like a flat wall and such. And this is because we're drawing our mask right at that exact position. So you're seeing any rounding errors, etc., making the surface kind of flash and such. So we're going to do one more thing here that we're going to actually modify as our trace results. We are going to go ahead and go back into our create cone function. And we're going to then extend these values ever so slightly. Let me go ahead and add another pin right here. Just want to try to move that a little bit. There we go. And so I'm going to take this directional vector that we have before we've added any distance to it. I drag out here, and I'm going to then multiply that by a float, and this is going to be basically we're going to use this to basically extend this vector that we've created, or this position, further into space along the line of the trace results. And so I'm going to grab that. I'm going to just multiply that by, let's say, 10 for now. And I'm going to add that over here. So, and this is what I'm actually going to then be saving into my array right here. And just so that we don't have any weird shapes going on, I'm going to do the same thing then for the results right down here. Go ahead and compile that. Now if I go ahead and hit play, if I run into a wall and such, you'll see that we're getting a little bit of overlap as it goes further into the wall, and I no longer have this kind of weird effect going on where it flashes. And you can begin pushing this even further if you want to, such that like you can see, you know, a decent chunk of the ceiling. You can try to make it smaller so that you get only the minimum possible. It's really, you know, entirely up to you. The other strange thing you'll notice is that based on how fine of our mesh we have, you're kind of getting different potential shape results right at the edge there. So this is where we can then modify our degrees and our num traces. So let's increase that from 20 to like 80, and we'll decrease the degrees per trace to like 1. Now if I compile this and hit play, we have a lot more traces, and we have a lot finer of a mesh that we're basically drawing to the canvas. And we can even go ahead and turn off this debug. And you can see here that we now have a very nice looking kind of vision cone system running around. Let's say there are certain types of items and such that you don't actually want to interact with this cone system. You can simply either add a custom channel, or what we can do here is I will simply find those boxes by first turning off this post-process we have. I'm just going to select these boxes then, all of these little template boxes. And since we're using a line trace, what we can do here is go over to our collision, and I'm going to go to custom. I'm just going to tell it to only do overlaps for the visibility, since that's the current trace channel we're using. Now if I go back and turn the post process back on, you can see that these boxes, for example, are no longer causing us to stop our vision system, but our projectile potentially still is. So you can do the same change if you need there. I do recommend using a custom trace for this rather than visibility, especially if you need visibility, to work later on for something else you're doing. In order to prevent this additional overlap effect here that we're seeing, we're going to modify our material real quick for our post-process to get rid of that effect. Let's go ahead and jump over into our vision system here, and we're just going to add in an if statement. We're going to go ahead and add a scalar. We're going to go ahead and plug this into the a is greater than b, and we're going to take the z texture for a equals b or a is less than b. And then for b, we're going to just leave that as is, and we're going to use a constant b of like 750. Basically, it's going to be whatever the maximum length of our trace is. And then for A, I just need to know how far away I am. So we're going to take our absolute position and our player position, and this is going to give us, this gives us a vector direction, so I just need to get the length. And I use the vector3 length and go ahead and plug that in. Add a reroute node for a little bit more cleanliness there. And now I will plug this into our alpha. Hit apply, and we can go ahead and run this. And now we will no longer see that additional kind of repeating tiling texture pattern that we were seeing beforehand. So the last thing then to cover is adding in some kind of small little vision sphere around our character, because right now all we have is this cone and you can't really see your character well. So let's go ahead and pop back into our line of sight vision material, and we're going to go ahead and add in a new little function here. So then right after this if statement, I'm going to add a pair of nodes in here. I'm going to first add a sphere mask, and I'm going to add this result to my if statement. Then I'm going to clamp that to make sure that we're only using 0 to 1 for the lerp. And for the sphere mask then, I'll leave the hardness at 100, and I'm going to plug in our position here to A, and I create myself a scalar here, and I'm going to use this as distance. I'm going to plug this into both B and the radius. Now if I increase this distance value, I can start creating a zone around my object that I can see in. So let's go ahead and leave this at like 120 for now. Compile this, and then I can go ahead and look here, and we can already immediately see that we now have a region around the player that they can still see inside of. And you can make this larger and smaller however you need it to be. And this is kind of a nice thing in case you want to give your player the ability to see like a little bit behind them just so that they're aware. And if you want to make it really small, you can do that too. So hopefully this has been a useful how-to tutorial for how to create your own line of sight vision system. I wish you luck with implementing it on your own games. Thank you for watching.